This is question number 24 from Chapter 8. It reads, calculate the net torque about the axle of a wheel shown in the figure. Assume that a frictional torque of 0.4 Newton meters opposes the motion. So as usual, friction opposes motion. It can change its direction. And torque is a vector, so it has a direction associated with it. I'm going to establish a convention. I'm going to say anything that turns it counterclockwise is going to be positive, and anything that turns it in the clockwise direction therefore will be negative. So I've kind of set my vector key, if you will, here in black. So, technically I could say, well, my net torque is going to be the sum of all of my torques, T1 plus T2 plus T3 plus my frictional torque, which is given to me in the problem. But I don't know which way that frictional torque is acting, so I'm going to kind of temporarily ignore it. And so then I'll say, all right, well, my net torque is equal to torque number 1, which I'll call this one here. This is my 18 Newton force, and all of these are at right angles here, so I need to know this lever arm. All of that information is given to me in the problem. It's 24 centimeters. So since that has a tendency to rotate the system in the clockwise direction, it's going to be negative. So I'm going to say 18 newtons times my distance, which is going to be 0.24 meters. However, that has to be negative. This term has to be negative. And then let's go ahead and take a look at the 35 newtons. Even though it's at this 135-degree angle, it still is perpendicular to the lever arm. So therefore, I don't even have to worry about that trigonometric component. And it is also counterclockwise because it's attempting to rotate this system in the clockwise direction. It's negative. So therefore, I'll say 35 newtons, and I'll multiply it by the lever arm, which is 0.12 meters, which was given to me in the problem. So again, another negative torque, force times distance. And then finally, this last one, this 28 Newton torque, is applied at the outer radius, and it's going to be a counterclockwise torque, so therefore it's positive. So it's going to be positive 28 newtons times 0.24 meters. So now the only thing that I've left out is this, which is fine. I'm going to add it here in just a second. So when I do that, I'll find out that so far my net torque is negative 1.8 Newton meters, and the only thing that the negative sign tells me is that it's attempting to rotate the system clockwise, which means then that the frictional torque is going to be in the counterclockwise direction, and therefore its direction is positive. I didn't know that until I did this step right here. So this is an important piece. So now, my revised definition of net torque is going to be this negative 1.8 Newton meters that I've now previously found, and I'm going to have to add to it a frictional torque of 0.40 Newton meters. And now that I've done that, I've taken into account the magnitude and the proper direction. I'm going to get a net torque of negative 1.4 Newton meters. You'll see a lot of analogs in this problem to stuff you've done previously in dynamics, and it's probably a good idea to kind of remember those and use those to help you navigate these problems.